In this example, I want to talk about model formulation in Excel. So what do I mean by a model? Well, a model consists of mapping inputs to a desired output. So in this particular example, our inputs would be the number of bags that we produce of dog food, cat food, and bird food. The outputs that we're actually interested in calculating would be the labor hours that are needed to manufacture those bags of food, the equipment hours that are tied up into manufacturing those bags of food, the raw materials that we might use in terms of the bags of food, and in addition, the total profit. So all of these cells that I have left empty, for example, the used and total profit, are outputs of this model. So we have to relate how inputs would affect these desired outputs. So the idea is that we can have any number that we would like to fill into this cell location or these cell locations, and we'll calculate certain things like the labor, the equipment, or the raw materials being used for any given combination of values that would be here. In general, this portion of the spreadsheet is the decision cells or the decision variables. This section, the second section, would be our constraints. The third section would be our desired output of total profit. So something that we perhaps later might try to optimize. So I want to comment briefly on the simple yet elegant structure of this spreadsheet, that we have everything listed that is related, physically related. So we have the bags produced, dog, cat, and bird. If we look at this table of information here, we're talking about the per unit labor hours, for example, of producing one bag of dog food, one bag of cat food, and C7, and one bag of bird food for the labor hour. So for every one bag of dog food, it's going to take 2 hours of labor, 2.5 hours for every cat food bag, and every bird food bag would take us 4 labor hours. So we have a capacity, if you will, of our labor hours available. So we want to model this dynamic relationship. So let's start talking about how you would model this in a manual fashion. If you notice in my spreadsheet, I actually have 2 worksheets, one manual and one we're going to use a Sumproduct. So you might want to begin by entering some numbers into your decision cells here. What I would recommend is just putting 1, 1, and 1 for now, of course. So when we start to model the total number of labor hours used with this combination, we would simply reference 1 bag of dog food times 2 hours for the dog food plus 1 bag of cat food times 2.5 hours of labor for every cat food bag plus 1 for the bird food bag times, and right now we actually can't reference the cell that we really want to, which is in D7, so we could either choose to type it D7, or if you click below the cell and just use your up arrow key, we can get there as well. Okay, so if we enter this equation, we're going to get the total amount of labor hours used with this combination. When I do put 1, 1, 1, it actually gives me a way to quickly check whether this formula is right. Because if this is 1, 1, 1, it should be, the total hours should be a sum of the coefficients here. So if I actually take and highlight this range, you might notice down here in your Excel, there's various things you can display. The sum is 8.5. If you don't have these options, you might want to right click and change here the things that are displayed. I tend to click all of the numeric summaries here. So anyway, we're just displaying 9. We need to display at least one more decimal for now. So everything checks out. If I was to enter 2 for all these, we should get 8.5 times 2 essentially. So 2, 2, and 2, which would be a value of 17. So it does in fact look like our model is right so far. So the next objective is to calculate the total equipment hours being used. So we might want to be tempted to fill this formula down, and I would highly recommend that. So why type this equation out? But we have to realize that if we fill this formula down, we don't want the locations of this cell location, B4, C4, or D4 to change its row position. So we're actually going to lock these row positions with a dollar sign. So in between B4, we're going to put a dollar sign to lock the row. Remember, putting a dollar sign before here, before the row index, would lock the row. If I put a dollar sign before the B, it would lock the column. Let's go to the next one, C4, lock the row, D4, lock the row, and hit enter. Now, if I fill this formula down, I have a way of formulating the number of equipment hours very quickly. 2 times 0.8 plus 2 times 1 plus 2 times the coefficient here that I can't see of 1.2. So we can fill this down one more. We have all of these filled, so we know exactly how many hours or equipment hours, labor hours, equipment hours, or raw material that's going to be used based on this arrangement. Okay, so now that we have the model formulation done for the constraints, if you will, we can see we're well under the available hours, and we'll address that a little later. The next thing to model is the total profit. So given that we know the total profit per bag, we should be able to calculate total profit. And in fact, it's set up in the same structure as the table above, which is why it's so simple yet elegant. So let's copy this formula that we've developed in the used column and paste it directly into the total profit. We could format that. So based on a combination of 2, 2, and 2, we're getting $400 of profit. So now let's assume that our monthly production of dog food was 50. The production of cat food was 100. And our bird food was 200. Now when we enter these numbers into our quote-unquote decision cells, our used cells, our calculated values, are updated. So now we can quickly look at a summary to make sure we're under the hours available. Certainly we are just under those hours. It does look like we have an excess of time in terms of not needing the total available time for the equipment because we're only using 380, and it does appear that we were under our total raw material. So we actually have a little bit of raw material available. In terms of our profit, we're down to $26,750 in profit. So now let's look at this same model formulation given the use of Sumproduct, which is a very useful tool. Okay, again, this is based on somewhat of experience to know how to formulate these types of sheets. But let's go ahead and enter the dog food amount of 50, cat food of 100, and bird food of 200. And let's use the sum product. So just as before, we calculate these exactly the same way, but we're going to use a function in Excel to make quick work of this problem. Let's use equal sum product. The array 1 will be the bags of food. Let's use our dollar signs everywhere to lock both rows and columns, comma, and let's reference B7 through D7 and leave this in a relative fashion and hit enter. Let's fill this formula down, copy this formula, paste it down into total profit, do a little formatting here, and we have exactly the same formulation. So it was very quick. So let's take a look at what this formula does, sum product. Well, it actually will take individual products of relative cell locations. So it'll take a product of 50 times 2. The next product will be 100 times 2.5. The next product will be 20 times 4. Then, after it takes all of those individual products, it'll simply take the sum of those products. So now it'll take the sum, the first product, 50 times 2, we'll add it to the product of 100 times 2.5, and then add that to the product of 200 times 4. So very nice, elegant, very useful function. And we simply can apply that down. We've locked the location of the bags of food, and this is simply moving down relative as to when we drag this formula down. And we can repurpose this formula, essentially reutilize it, copy and paste it down to calculate the total profit.